So a rocket ship is 10 meters above its launch pad. So if this is the launch pad, it is here. Let me see if I can do. Okay. This is 10 meters above the launch. A man is at this in a distance 7 meters away from the launch pad, so somewhere here. And running away. So my picture is kind of showing the guy is running away. With what speed? It's running away from the pad in the 3 meters per second. The rocket ship also going upward with a speed or velocity of 25 meters per second. Now the question is, find the rate. So we are trying to find rate of something, of the distance between the rocket and that person there. So this D. Okay, so first let's start modeling. So first thing is that identify all variables here or quantities. So first thing, well, the one that we are going to find is the distance between, so distance between the rocket ship and the man. So that's the one of the things. Another thing is that, well, the distance of the guy from the launch pad. So distance between the man and the launch pad. And there's also another one, the distance of the rocket from this, the rocket and the launch pad. So three different things. These are the only things that are changing. The rocket is going up, the man is running away, and then the distance is changing between these. So for each one, we have to make a name, a variable. So I will put capital D for the first one. For the distance of man from the launch pad here, I use X. For the distance between the launch pad and the rocket ship, I will put Y. So that's the first thing. Then, well, I want to rewrite everything in terms of these variables. What is here given is that the rocket ship goes up in terms of with the velocity of 25 meters per second. So that means that dy dt is 25 meters per second. dx dt, how fast the man runs away from the launch pad, it is given 3 minutes per second. And then the question is, what is the rate of dx dd dt? So how the distance between these two guys, so I should use the capital D here, the distance between these two guys changes when the person from the launch pad has a distance of 7 meters, and the rocket ship is about the launch pad with 10 meters, about 10 meters. So that is my question in in terms of in terms of these variables. But then we have to find the relation between these guys, relations between the variables. So here, when you look at very schematic way here, so this is the rocket going up, this is the man running away, this is the launch pad. We have a right triangle here. This is y, this is x, this is d. Yes. So basically what we know is d squared is equal to x squared plus y squared. Okay. Now, well, this is what we have. This is modeling is done. We have now very mathematical question, and we have to solve that. We want to find the how the rates are related. So to do that, we differentiate the whole equation, both sides of the equation with respect to t. When you're trying to find the relation between the rates, you differentiate both sides with respect to the third variable t here. So this will give us 2 dd dt d to the power 2 minus 1, 2 dx dt x, 2 dy dt y to the power 2 minus 1. Well, I actually now know all the values but one. So 2, let me write on the right-hand side, 2 dx dt is 3, x is 7, 2 dy dt is 10. Sorry, no, dy dt is 25 actually, and y is 10. Okay. On the right hand side, we don't, on the left hand side, we don't know what is dt. How about capital D there? Oh, okay. When d is, I have to use this equation. When x is 7 and y is 10, then d squared is going to be equal to 49 plus 100. And then d itself is going to be root 149. So this is what we will get. Okay, so this is now dd dt is equal. This whole thing will go to the denominator of the right-hand side. Here, 2 times 3, 6, 7, 42, plus 50, another, this is 500. So 542 over 2, 140. And that is how fast, this is meter per second, how fast the distance between the man running away and the launching or flying rocket ship increase.